All right, so the next kind of direction that we're taking here is we're going to work on solving polynomials, okay? So you remember with quadratics, we had 5 different methods for solving. One is graphing, which is something that we're still going to do with polynomials. One is factoring, which is something we're still going to do with polynomials. So today we're going to start looking at how to factor polynomials with one particular type of factoring, okay? Now, the other 5 methods that we had, completing the square. Well, completing the square is something that is specific to quadratics, right? Because we always started with an x squared and then we tried to make it a squared term, right? So completing the square is not something we're going to do with polynomials. The quadratic formula, if you remember, the quadratic formula is just completing the square and kind of rewritten in a different way. So that also isn't going to work for polynomials. Okay, so of our 5 methods, and then the last one was square roots, which there's a variation that you can sort of do for square roots, but we're not really going to do that too much. Okay, so we're going to go through solving, and one of the big ones is solving by factoring. So we're going to look at a bunch of different ways that we can factor so that we can use that to our advantage. Okay, so the first one that we're going to talk about is a sum or difference of 2 cubes. So when you have 2 different things that are cubed that are either subtracted or 2 different things that are cubed that are added. Okay, and there's basically just this little formula that you memorize, and then you should be able to go from there. Okay, so I'm going to help you give you some tips on how to remember that. But the first thing I want to do is just show you that this does indeed work. Okay, so we're going to do kind of a little mini proof. It's not technically a proof, but we're just going to simplify this factored form and show that if you actually multiply this out, you do indeed get this. Okay, so let's take a look at this. So the first thing that I'm going to do is distribute the a, right? So that's going to give me a cubed plus a squared b, and then plus ab squared. Okay, and then I'm going to distribute the minus b, right? And negative b times a squared. So I'm going to write that here, but I'm going to write it as negative a squared b, right? Just put them in a different order. And then negative b times ab, that's going to be a negative ab squared. And then negative b times b squared is negative b squared. So you can see that when we combine these cancel out and those cancel out, right? So I'm left with just a cubed minus b cubed. Oh, sorry, that should have been a cubed, right? So you can see that when you multiply this out, it actually does work because those middle terms end up canceling. Okay, so this is just a way that you can factor a difference of 2 cubes. And as you can kind of guess from here, this would be a similar proof. I'm not going to do both, but it would similarly work out where those middle terms would cancel. Okay, so here's how we're going to do this. So here's the trick that I use to remember both of these, because you're going to notice that they're pretty much the same factorization, just the signs are a little bit different. Okay, so here's how I kind of remember this. First thing that I remember is that these signs here should match. Okay, so if this is a minus, then so is that. And the same thing happens if I look down on this one, right? These two match. Okay, so those are going to be the same sign. Okay, and then the next sign, this guy, is going to be the opposite of whatever the original one was. Okay, so these guys here, those are the opposites. Okay, and you'll see that happens down here as well. These two are opposite. Okay, so you can kind of remember that. And then the last one is always a plus. Okay, so this guy right here is always a plus sign. Same thing down the next one. This is always a plus sign. Okay, so if you can kind of remember that, the first one's match, the second one is opposite, that's going to help you out. Okay, and then A and B are basically just the cube root of whatever these two things are. Okay, so the way that I think about this, I didn't memorize this in terms of letters. I just kind of remember it like, okay, so I'm going to take the cube root of the first thing, matching sign, cube root of the second thing, cube root of the first thing squared, product of the 2 cube roots, right? Or sorry, opposite sign, product of the 2 cube roots, and then plus the cube root of the second thing squared. Okay, so it's just like, it sounds really complicated when you say it, but if you can just sort of remember like what's going on, that's going to help you out a little bit. Okay, so let's look at a couple of examples. So x cubed minus 27. The first thing you need to do is figure out what is the cube root of both of those things. So x is the cube root of x cubed, and 3 is the cube root of 27. Okay, and then that's what we're going to use to factor this. So it's the first thing, x, matching sign, the second thing, 3, right? And then the first thing squared, so x squared, opposite sign, product of the two things, so 3x, and then plus the second thing squared, so plus 9. Okay, and that's it. All right, this will never factor farther. Okay, so when you do a difference of two squares or a sum of two, or a difference of two cubes or a sum of two cubes, this part here will never factor more than that. Okay. All right, so let's take a look at this guy. So this one's also a perfect, a difference of two cubes, right? The cube root of x squared, of x to the sixth is x squared, right? X squared raised to the third power. You do x squared times x squared times x squared, that's 6x's, right? And the cube root of 8 is 2. So this is going to factor to first thing, matching sign, second thing. First thing squared, so x squared would be x to the fourth. Opposite sign, product of the two things, right? And then plus the second thing squared, so plus 4. Okay. This guy, you know what? I'm even going to say let's skip this guy. Let's not worry about this one. You're not going to have anything quite that complicated. But you could also look at this one and do that as a difference of two cubes. But we're going to skip that one for now and jump down to the next one. So this one, when you first look at it, this one's not a difference of two cubes. But we can rework it a little bit and make it work out because it has a GCF. So you always want to factor out a GCF first. So I can factor out a 3x. And that's going to leave me with x cubed minus 8, right? This, cube root of that is x, cube root of that is 2. So for my final answer, I'm just going to copy over the 3x. And then it's first thing, matching sign, second thing. First thing squared, opposite sign, product of the two, and then plus the second thing squared. Okay. And there we go. All right, and then these guys down here, very similar, right? And if you kind of think about it the way that I've been sort of saying it as you go through here, then you don't have to worry about memorizing two different formulas. You can just sort of roll with it, right? The cube root of x cubed is x, cube root of 27 is 3. So this is going to be first thing, matching sign, second thing. First thing squared, so x squared. Opposite sign, product of the two things, plus the second thing squared. Okay, so it's technically there's two different rules here, but if you think about it the right way, you can make it one rule. This guy, cube root of 8x or 8y cubed is 2y, and the cube root of 1 is 1. So first thing, matching sign, second thing. First thing squared, so that's going to be 4y squared. Opposite sign, product of the two things, plus the second thing squared. All right, and then one more. So the cube root of 125x cubed is 5x. Cube root of 27 is 3. So this is first thing, matching sign, second thing. First thing squared, so 25x squared. Opposite sign, product of the two things, plus the second thing squared. Okay? And that's it. That's how you're going to factor a sum or a difference of two cubes. Okay, so it's just something that you kind of have to memorize. It's a pattern that you really just got to drill into your brain, and that's going to help you to factor some stuff.